All right, so we have a system of three equations. I'm going to begin by rewriting these three equations a little bit bigger. All right, to solve a system of three equations by elimination, what we do is we pick any two of the equations and eliminate one of the variables. It doesn't matter which two equations we pick, and it doesn't matter which variable we pick. It's just based on what's easiest. Notice that if I pick the second and third equations, I can add them together, which would eliminate the z's. So I'm going to pick these two equations, and if I add these two equations together, I'll get x plus y equals 0. Right? So I have the y plus the x, and so I wrote that as x plus y's. The z's would cancel out. And then if I add the negative 5 and 5, I get 0. So this is the equation I get if I add those two equations. Again, I could pick any two equations and eliminate any variable I want, and the answers would be the same in the end. Once we do that, we bring over the other equation, and what we've done is we've turned the system into a two-variable system. Now the system just has two variables, and we would proceed from there. Notice that we could add these two. If we add these two equations, it would eliminate the y. So if I add these two equations, I would have 2x, and then the y's are eliminated, equals 12, and then x equals 6. Now we back substitute. We're going to take x equals 6, and we can plug it into either one of these two equations. Let's see if x equals 6, I'll use this. Doesn't matter. I guess I'll use this bottom one. And so I get plugging 6 in for x, 6 plus y equals 0. And so I see that y is negative 6. So I've got x, I've got y. And then I take these two answers and I plug it back into one of these two equations at the start. I guess I'll use the third one. The third equation is x plus z equals 5. And I know that x is 6. And so after subtracting 6 from both sides, I get negative 1. And so the solution to this, the ordered pair triple, we write as x, y, z. It would be 6, negative 6, negative 1. Once we have a proposed final answer, it could be validated, it could be checked by plugging in, making sure that these numbers work into all three of the original equations. So again, to solve a system of equations with three variables by elimination, we begin by picking any two equations and eliminating one of the variables. And then we take that result and put it back with the other equation, the one that I didn't use, and we should have a two-equation system at that point.